Welcome to part 2, where we are going to talk about writing sequences as functions. So for arithmetic, we're going to start. So we're going to say let a sub n, think like submarine, it's below, be the nth term of an arithmetic sequence with a first term a sub 1 and a common difference d. So finding the nth term is given by this formula. You don't have to memorize it. You get it on your test on the EOC. You just have to know how to use it. So we have a sub n equals a sub 1 plus parentheses n minus 1 parentheses d. Okay? So right here, multiplication is happening because we know parentheses mean multiply. So whatever your common difference is being multiplied by your n minus 1 term. Again, this a sub 1 is standing for your first term in your sequence. A sub n stands for any term, like n could be the 5th term or the 100th term or the 15th term. Okay. So example 6, write an equation for finding the nth term of the arithmetic sequence 55, 40, 25, 10, and then find a sub 16. So kind of two parts. The first part is to write an equation. To do that, you have to figure out the pattern. So how did they go from 55 to 40? Well, they went down, and it's arithmetic, so they probably subtracted. Again, if you don't know, pick a number, subtract the one before it. So 40, take away 55. I know they're subtracting 15. Okay, so that is our common difference, subtracting 15 each time. So common difference, negative 15. The next thing you need in your equation is your a sub 1, which is the first term. So you just have to look, hey, 55 was the first term. So that's the two pieces of information you need to write your equation. So we're going to start with a sub n equals a sub 1 is 55 plus parentheses n minus 1. Now I'm going to put a times just to represent multiplication. Our common difference was a negative 15. Okay, so here's our equation. That's our answer. Now you may see it written differently. You may see it written like this, where they put this common difference in the front. And so I would do negative 15, because I'm being subtracted by 15, and minus 1. Now again, both equations are the exact same. They are both correct. In my opinion, the second one is a little bit easier to write, because you don't have to have this times. But it's up to you. The next thing we could do is simplify this expression to kind of look more like slope-intercept form. To do that, you would distribute your common difference to the n minus 1. So negative 15 times n is negative 15n. A negative times a negative is a positive, and so 15 times 1 is a positive 15. And then this first term will always drop down. Lastly, you can combine like terms, which will always be this first and this last term. So our final answer would be a sub n. Your slope is that negative 15n, and then 55 plus 15, if you add those two, you get 70. Okay, so this is kind of simplified. However, again, this answer is fine, as well as this answer. Delta Math would accept all of them as a correct answer. The last one is just more simplified. Okay. Now, so that was part 1 of the equation. Write an equation. Part 2 says, hey, find a sub 16. So what that means is the 16th term. So here's the first one, the second one, the third one, the fourth one. If I keep going, what would be the 16th term? Now that would be kind of annoying to write out by hand. So our formula actually tells you the answer. So I'm going to use this last one because it's more simplified. So to find a sub 16, you're just going to plug in 16 for our n. So I would have negative 15. Our n is 16. That's the number I want to find. And then add 70. And then type that in the calculator, and there's our answer. So negative 15 times 16 plus 70. So negative 170. So if I continued this pattern over and over and over again, the 16th term would be negative 170. Okay? So writing an equation for an arithmetic sequence really helps you predict like a future number. You could figure out the 100th term without actually listing them all out, which is why this is beneficial. All right, you guys try the next problem. So see if you can write an equation for the pattern 2, -2, -610, and then, hey, tell me the 20th number of that sequence. So press pause and try that. All right, so starting off, these are our answers. So your first term was 2, a sub 1 was 2. Your common difference was subtracting a 4. So when I write my equation, I would have a sub n equals 2 plus n minus 1. Now that's being times by a -4. So again, if you wanted to write it backwards, you could have written a sub n equals 2 minus 4 times n minus 1. Again, they're both the same. You guys do you. We do like to simplify it. So you would have -4 times n, which is -4. Negative times a negative is a +4. Drop down the 2. Combine the 2 and the 4 to get 6 with your -4n in the front. So again, either of these are correct answers. They would all be accepted. On a multiple choice test, you just have to identify the correct one. And then the 20th term, again, you can plug it into either of these. I think the last one's the fastest, less typing. -4 times 20, and then plus a 16. So the 20th term would be -74 if you did it 20 times. So that is writing a function of an arithmetic sequence. So let's talk about geometric sequences. So if you remember, geometric was exponential, and so our geometric function is going to look exponential. So again, let a sub n be the nth term of an arithmetic sequence. That should say geometric. Typo. With the first term, a sub 1, and then a common ratio, r. And so our equation is a sub n equals a sub 1, parentheses, r to the n minus 1. So again, n minus 1 is still in our problem, but it's in the exponent spot since I have a geometric function. So same two things. You need your first term, and then you need your common ratio for this problem. So again, first term is pretty easy to find. It's the first number. It's 2. The common ratio is what are they multiplying by? So how did they go from a 2 to a 12? They multiplied by 6. 6 times 12 is also 72. So hey, my common ratio is a 6. So if I'm going to write an equation, I'm going to start off with a sub n. Your a sub 1 was 2. Parentheses, your common ratio is 6. And then n minus 1. And we're done. So that is the equation for finding the nth term. If we wanted to, we could simplify this. I'll show you. So I'll have a sub n equals 2, and we'll do 6 to the n, and then that 6 would also get that exponent of a -1, okay? I know that 6 to the -1 power is the same as 1/6, because if you have a negative exponent, that base is going to go to the denominator. I'll drop down the 2, and then I'll drop down the 6 to the n. The last thing we can do is simplify these two. And so if you multiply them, you would have 2 times 1/6. So let me do that. 2 times 1/6, which would be 2/6, which reduces to 1/3. Okay, so then this final answer, if you simplified it, would be a sub n equals 1/3, 6 to the n. Now again, this would be acceptable to leave it. You could also possibly see that on a multiple choice test. It's kind of up to you guys. So now we're going to find the 10th term. So to do that, we're going to plug in 10 into our n value. So you can either use this equation or we can use this equation over here. I'm going to use this first one. So to find a sub 10, you would have 2 times 6 to the 10 minus 1. And then we just type the entire thing into our calculator. So 2 times 6 to the 10 minus 1, which gives us a massive number. Because if I were to multiply 6 over and over and over again 10 times, we would get this number. So 20,155,392. That would be the 10th number if you multiplied by 6 10 times. All right, you guys try this last one, and we'll go over the answer. All right, so in this last one, the most common mistake is to have a common ratio of a 5, because you're like, oh, it's dividing by 5. But when you are writing a geometric sequence, you really have to put it in terms of multiplication. So yes, you could say, hey, they're dividing by 5, but that is the same thing as multiplying by 1/5. Again, if you don't know, pick a number, divide the one before it. So your common ratio is 1/5. Again, that's decaying, so your ratio needs to be smaller than a 1 if you remember exponential unit. So you've got 750 for your a sub 1, parentheses 1/5 to the n minus 1. Again, I'm going to leave it like that. If you wanted to simplify it, you could. Not necessary. So finding the 8th term, if you plug in 8, you get 6 over 625. So that would be the 8th term if you kept dividing by 5. Cool? All right, let's talk about some real-world problems. So, modeling in real life. So, online bidding for a geothermal heat pump increases by $25 for each bid after an initial bid of $420. So, part A, write a function. So, again, to do that, you need to figure out your a sub 1 and then our common difference. So, our first term we know is 420 because that was my initial bid. Our common difference, they are increasing by $25, so that is our common difference. So let's write our equation. So a sub n equals, it's a sub 1, so 420, plus parentheses n minus 1, times that by our common difference, which is 25. Again, that's our answer. If you want to leave it, great. I like to simplify it because it helps me solve it later. So first step to simplifying, we're going to distribute. So drop down 420. 25 times n is 25n. 25 times negative 1 is negative 25. Combine like terms. 420 take away 25 is 395. And drop down our 25n, and that was a positive 395. So here is our simplified equation. It looks like y equals mx plus b. It looks very linear because it was an arithmetic function. Now, for part B, the winning bid was 1,520. So how many times did people bid? So in this case, my a sub n is that number. So I'm going to plug in 1,520 for my a sub n and figure out my n value, or how many bids there are. So to do this, I'm going to solve a normal two-step equation. I'm trying to get n by itself, so we would subtract 395 from both sides. That would be 1,125 equal to 25n. Divide by 25 to get 45. So that means they bid 45 times until they finally won the cool geothermal heat pump for that price. So we have run out of time in this video, so I'm just going to stop it here. You can try example 9. The answer key is located on Canvas if you want to check your work. So thanks for watching Arithmetic and Geometric Sequences. I lied, I have 30 seconds left. So here, hopefully you press pause, would be the answer to solving this real-world problem. They were multiplying by 2, so this time we set up a geometric equation. 640 would represent your a sub n value. You do have to solve an exponential. Divide by 5. The opposite of an exponential is a log, so logs come back, yay. Real-world problems, geometric sequences. Thanks for watching.